This lesson is going to talk about patterns and linear functions. In a relationship between variables, we have a dependent variable that is going to change in response to another variable called the independent variable. So the dependent variable is going to depend on what the independent variable is. An example of independent and dependent variables. So an independent variable might be the number of hours studied for a test. So if you're a student, you can choose to spend an hour studying, you can choose to spend 30 minutes studying, you can choose to spend no time studying. But your test score is going to depend on how much you study. So independent would be the number of hours you study, dependent would be the score that you make on the test or your test score. If an independent variable is the number of books read in a year, the dependent variable might be your reading level. So the more you read, the higher your reading level is. A dependent variable might be your level of boredom or how bored you are. Your independent variable would be what you choose to do. So if you choose to sit on the couch and watch TV, you might be bored. If you choose to get up and go play outside, you might be less bored. You have the choice of what to do, and then your level of boredom is going to depend on that. And then if your independent variable was your annual salary, your dependent variable might be how or where you live, and then vacations that you go on, just your life, what you're able to do. If your salary is low, you're going to be able to do less. If your salary is high, you might be able to do more, go on more vacations, or go on like bigger vacations, that type of stuff. Values of the independent variable are going to be called inputs when we start talking about functions, and values of the dependent variable are going to be called outputs. This example says, what is the relationship between the number of vertices in each polygon and the number of isosceles triangles? If you remember, vertices are the angles or the points where two sides meet. The number of vertices for the first shape would be 4, and the number of isosceles triangles is also 4. The middle shape, we have 5 vertices and 5 isosceles triangles. And the third shape, we have 6 vertices and 6 isosceles triangles. So the number of vertices is equal to the number of isosceles triangles. What we're starting with here is the shape, right? The polygon is there first, and that's what has the vertices. So your independent variable is going to be the number of vertices. Your dependent variable would be the number of triangles. If you have 7 vertices, you'll have 7 triangles, and so on and so forth. In the diagram below, what is the relationship between the figure number and the number of squares in the figure? How can it be represented? So I'm going to go ahead and organize my data in a table. If you look at figure 1, you'll notice that it has 5 squares. Figure 2 has 9 squares. And figure 3 has 13 squares. So I'm going to set up a table to show that relationship. The figure number is my x value, and the number of squares is my y value. The figure number would be my independent variable. The number of squares would be my dependent variable. So you're always looking for a pattern on how you can represent or how you can get from your x values to your y values. So you always want to check for addition or subtraction and multiplication or division, like a one-step equation first. So if you look at the first row, we have the figure number is 1 and the number of squares is 5. So you could either get that by adding 4 or by multiplying by 5. But if you look down at the next row where we have figure number 2 that has 9 squares, if you multiply that by 5, there should be 10 squares, and there's not, there's only 9. If you add 4 to that, you should have 6 squares, and there's not, there's 9. So we know that this is going to be at least a two-step equation of some kind. And if you look at that and you kind of think about it for a second, you might find that what you can do is you can multiply the figure number or your x by 4, and then you can add 1. So 1 times 4 is 4, plus 1 is 5. 2 times 4 is 8, plus 1 is 9. 3 times 4 is 12, and 12 plus 1 is 13. So I can represent that using the expression 4x plus 1, and I can write it as an equation, y equals 4x plus 1. So it can be represented in a table. It can be represented using the equation y equals 4x plus 1. You could also choose to show this in a graph if you so please. That would be another way to represent. A function. A function is a relationship that pairs each input value, or x value, with exactly one output value. So for every x value, it can only have one y value. A linear function has a graph that is a non-vertical line or part of a non-vertical line. If it's a vertical line, it is actually not a function. The last example says, the table shows the amount of water y in a tank after x minutes of being drained. Is the relationship a function? Describe the relationship using words and an equation. So if you look at this, the car wash grand opening, the time x in minutes, after 0 minutes, there are 440 gallons of water. After 1 minute, there's only 428 gallons of water. 2 minutes, there are 416 gallons of water. And after 3 minutes, there are 404 gallons of water. So this is definitely a trend that is decreasing, right? As time increases, the water in gallons is decreasing. It is a function because for every input, for every x value, which are 0, 1, 2, and 3, there is exactly one output or y value, right? When x is 0, there are 440 gallons of water. That's for sure the number of gallons of water at 0 minutes. It doesn't have multiple different values at 0 minutes, and the same for 1, 2, and 3. So we're then asked to describe the relationship using words and an equation. So we need to look for a pattern here. And the pattern, if you go down the y column, we start with 440 gallons, and then we go to 428, which is subtracting 12 gallons of water after 1 minute. And to go from 428 to 416, again we subtract 12. And to go from 416 to 404, again we subtract 12. While the water is decreasing by 12 every time, the minutes are increasing by 1 every time. So we go from 0 to 1, 1 to 2, 2 to 3. Each one is 1 minute more. So we can say y is 440 minus 12 times the number of minutes x. Or we could write it as an equation, which is y equals 440, the number of gallons of water at 0 minutes, minus 12x, because for every minute, the gallons of water are decreasing by 12 gallons.